Like the slides.
Oh,
Am I
okay,
sharing?
yes, we can see it.
All right, cool. So, welcome to week 5, I think, of the MoE reading group. Today we're going to be covering ModuleFormer, which is a paper from IBM. Um, the TLDR is basically, you know, ModuleFormer lets you add or remove experts from an MoE after training it by doing like a separate fine-tuning step on some domain-specific data. Um, and Yeah, Buttercutter, could you mute your mic is making some noises. Thanks. Um, yeah, and so after pre-training, you do a separate fine-tuning step, which then allows you to like remove experts or also add experts. And by adding experts, you could sort of add knowledge, and by pruning experts, you could make the model more efficient and use less memory. And the way they do this is by sort of reparameterizing the router, making it two matrices, and then making one of the matrices, the matrix A, sort of expandable. And I'll cover like how you do this with code later, and how you train it after you add a
So,
new
what does the h prime function represent here?
uh it's the router result, so it's like what you get. It's the router probabilities basically. So like with STMOE, this would be like a single linear linear layer. But yeah, I'll go into like how this exactly works a little bit later.
Thanks.
I have like some code. But another thing that I sort of noticed is like they released, like Hugging Face code. So, from that my thoughts are kind of like, oh, we want to be the default like MOE model that people use. Um but I'll share why I have like some issues with that, since, there's a few like weird quirks that they add that aren't like super necessary. Um, like one thing that I found pretty weird is that they don't even use like positional embeddings. They use some kind of um like probability process thing, which I haven't like fully read through, understood, but I'll go into that too. Um, the first like comparison I sort of wanted to make to like the way that they add new experts was Laura, because I think there's a lot of parallels there. You have like some new data or some new thing that you want the model to learn, or like you want to somehow change the model weights to behave a certain way without like fully uh like pre-training. And with LoRa you have your low rank adapter that you add to each layer output. It's very few parameters, because like matrix B is like both of these matrices are low rank, so they're like dimension model, and then by like 16 or 64, so they're very shallow. But this idea of like modular neural networks is a lot older. um, and what basically what they show here is like under a set of constraints there are actually like use cases where you could where it would make more sense to train a new module instead of using something like LoRa. Um, the architecture looks a lot like a standard MoE model. It has top K routing. Um, the the routing probabilities, like you multiply the inputs by a matrix B, then you apply an activation function, and then you multiply it by a matrix A. But it essentially gives you the same output shape as like a regular MoE router, similar to what we've been talking about before. Um, but this like representation of two matrices lets you do things like change the size of A, or also just delete rows from A to sort of remove individual like experts. Um, and like the code here looks a lot like again your average like MoE, top K, like sparse MoE. You uh you get like top K indices from a top K function from your um like router outputs, and then you use your indices to like you feed them to each expert, so each expert actually like processes um a set of indices that the router sort of thinks that it's like going to be you know the best for, or like the indices assigned to it by the router. And this code is just from their GitHub, which I linked in the chat, but it's it's like Hugging Face compatible. I think it's like okay code, so you could actually just like go over it. Um, Here's how the router is different from like a regular MoE router. You have like experts here is B, and then expert outputs is A. So you apply your experts, or you apply B, and then you apply your activation function, which is like ReLU, and then you apply your A. And here's some like sort of pseudocode for how you would actually add an expert. So we have a matrix here A. It has dimension, like the dimension is number of experts by like D model or D router. And to add an expert, you sort of need to do three things. The first thing is to add a new dimension to this matrix A. Um, you basically initialize a new matrix. You fill in all the previous rows, and then your new rows are just like random parameters that you train later. So the new dimensions of A are like your new number of experts by D router. I'm gonna I'm gonna go over the code, but then I'll stop if anyone has any questions. Um, you then like add a new expert layer. So here I'm like representing them as like a module list. Um, and you have to make it like an expert mask. So whenever you add a new expert, you freeze like all of the sections of the router corresponding to the existing experts, and you only train like that strip that you added um, to your new expert layer. And so the mask would look like zeros everywhere except for that row, like corresponding to the new expert. And then when you actually train it, like you actually like zero out the gradients for everything in the router except for that row. So yeah, I'm gonna stop here. Does anyone have any questions so far?
Why does the model ever choose to use the new expert that is completely randomly initialized if all things equal, the previous expert weights that existed should be a lot better at predicting the correct output,
You
right?
yeah. You use a loss during this like fine tuning step. Basically, this is fine tuning, right? You add a new expert, and then you do like fine tuning with that new expert, and that's basically the use case that they wanted.
Yep.
But if I go down here, they have a special like loss that they do during this fine tuning step that like minimizes. Um, yeah, they do like this mutual information loss. So basically, this is like the reason why uh, the model chooses to use the new expert, right?
I see.
But I'll sort of go over that. But Here's like some more code to prune a module, and very similar. You just you remove that index from the router, and then you remove the entry from your list of experts, and then you like that's your new layer. Um, Instead of the loss in STMOE, which is like this dot product, which I think we went over a couple times. Um, they use something they call mutual information loss, where you're maximizing the mutual information between the tokens and the modules. Um, and it sort of reduces down to this. So like this first part, um, make sure that like the total, I guess like the total probabilities are minimized. Uh, and then this part like penalizes a large part. Like it penalizes the probability of a module given an input like being too small. So you're actually maximizing that probability. So you want the probability of like, okay, given like some input X, it's able to very easily figure out what the right module is. At the same time, you want all the modules to be kind of smaller. Is how I would sort of think about it. And yeah, I mean, I guess this sort of accomplishes the same thing as this loss. They have like a little diagram here of like the KL divergence between different domains of the pilot test set. So the idea here is like, okay, we want different, we want a high divergence between like, like math and like a law or something, or um, like GitHub and like books. And you would want, um, you would also ideally want that to be like assigned to different experts. Um, but then I sort of like had this question of, if you're doing pruning, like how would you make sure that the right that you keep the correct experts for the task that you're trying to accomplish while also pruning the model and like removing experts? Um, that might actually be a good like a good reason to do this. Um, if you want like a specialist model instead of a generalist model that's also pruned. Like if you want a model that only does like math and GitHub, you would want high divergence between like a whole bunch of topics. And during fine tuning, they add this like loss term. Uh, Essentially, here they're doing the opposite. Like they want the experts to be as different as possible, and then that's like done to prepare the model for pruning. Um, and so I guess you're essentially doing like two steps here. So you're doing your pre-training step, which uses this loss, and then you're doing your fine-tuning step if you want to prune the model, where you use this instead. And I guess this would be used for like less training steps, and it would be used like on a small like fine-tuning data set that's domain specific.
Wait, so this fine-tuning loss tries to maximize the divergence between the experts
Yeah.
and
I mean, it's
the
essentially
and
yeah,
the initial.
because this term is negative, and then if you go up here, like this is the same term, but this is trying to minimize the divergence, right?
But
So
if it is trying to minimize the divergence, then why is it that in the heat map with the KL divergence, why the value is higher with their loss rather than the STMOE loss?
well, that might just be like a feature of the loss. I
No,
mean,
but
there's still like some,
like you
yeah.
said that they're trying to minimize the divergence, right?
Uh, well, yeah, but there are two terms here.
I
There's
see.
like I mean, I guess it's not like it's not a one-to-one thing between like the scale divergence and like I guess it's like a different definition a little bit between the KL divergence and like trying to specialize
I see.
the experts. Um, but yeah, like it does have more divergence than like the regular STMOE laws.
Mm.
Um, yeah, but I would guess that if you do this, then like this would be even more extreme, and essentially that's what you would want, right? Like if you're trying to prune experts,
Right.
you would want them to be different and sort of not have a lot in common with each other. Um, yeah, and so then there's like a few other details which I don't think are very important to the actual architecture. Um, One of them is this like stick breaking Dirichlet process. Essentially, well, this model doesn't have positional embeddings, and so the actual position, like um the positional like signal is in the attention layer, and they do they treat each attention head as like a marginal distribution, and they sample from it, and in that way they sort of they claim that like this does the same job as a positional embedding. Um, to have a good idea for how this works, you'd probably need to read a little bit about like stake breaking and like probability. Uh, so I didn't really have the time to like cover this super well. But from the results that they gave, like it does do like for their specific use case, it does do a little bit better than like rotary positional embeddings. But I think that like this isn't even super important. Like it doesn't have a lot to do with the rest of the architecture. At least like not in a way that they explain.
I-
Um yeah, and like here's like the results. So
Is there any part of your slides that shows the difference between rotary and their stick breaking stuff?
no, but there's a plot in the paper that shows the difference. It's like not a huge difference. It's like I don't remember, but it's not huge. They just added a whole bunch of like they did an ablation study with like their new loss versus the STMOE loss, and then also the stake breaking thing. I don't have it in my slides though, but
Mm.
it's in the paper. So
But
what I like about the results,
they have a
yeah,
rule for stick breaking plus softmax and rope, which are they supposed to
yeah.
be combined or
Actually, like if you read like the way that they define like the stake breaking plus whatever, it's confusing. I don't know why they said stake breaking plus mutual information if it doesn't have mutual information. Like um yeah, I don't have it like off the top of my head which one is has stake breaking, which one
I see.
doesn't. But I remember like the way that they named the like the sections are is kind of confusing. Okay, so the results like what I like is finally like no more T5. We have like an actual like decoder only model, and we could compare it to models like GPT Neo and like Pythia. And if you compare it that way, I think the results are pretty good. I mean, especially if you consider like the number of parameters. Like 4 billion isn't that much more than 1.4 billion. It has a two times lower latency, but the results are like comparable. And you know, the interesting part here is like it's modular, so maybe you'd even be able to prune it and get like better results uh for like a given like VRAM budget. Um, the K2 and K4 basically they're like the top K, and K4 does better than K2, but it's also gonna have two times the latency. Um, they yeah, so they do like comparisons with like code generation as well. Um, and that was actually the like how they applied the pruning thing was they made like they applied it to coding. So they tested it on human eval, they tried their like fine tuning like with the loss and the pruning, and what they found is that you could prune um like you could prune about like 30% of the experts without like a huge loss in like human eval. Um you could also, yeah, and then like they tried pruning with expert frequency. Uh it's sort of common knowledge that large language models are sparse. And like an interesting application is like, yeah, what if you could just make like models that are domain specific that use, much less memory, but still have like better performance than, like a dense model.
Did they discuss the D type of any of their inference or evals?
The D type?
Yes.
No,
Yeah, because like
nothing that
I,
I
I
saw.
always feel that it's important in general, like not just for this ModuleFormer and not just for STMOE dropout stuff, but even for general sparsity papers, none of them ever mentioned the performance of their models when they try and when you additionally apply like the standard quantization techniques on top of them. So like for example, sparse GPT, which cut the model parameters by 50%, is very exciting if you look at it from an FP16 perspective. But if you consider that most dense models are also inferred under a 8-bit or even 4-bit paradigm, then the idea of pruning a model down to
Yeah.
30% is no longer as alluring.
You could do both, and also like I have an example of people doing both, which is deep sparse. Also, I think this is a good first step. Like you want to do this like one step at a time, because if you try to do like quantization and pruning,
Yep.
you might just say like, oh, this the results suck. Like none, like both of these don't work, but actually like one of them might work. So I think it's important to try to do like the pruning thing first, and then do like quantization.
Well, yes, but that's the important point, right? Like,
Yeah,
quantization
the
sets
D
this
type, the
extremely
D type
powerful
is
baseline that,
yeah, yeah, yeah. The D type here is floating point 16. The router is in FP32. If you're going off of like like that's probably what it is, right? Because
mhm,
the router is pretty much identical to the like STMW router. The router is always in like full precision floating point 32, and then the rest of the model, well, it hasn't been quantized, so it's probably an FP16.
right?
Uh, so that's just what I would guess. I mean, it's in their GitHub, so you could probably like Hugging Face models are usually in FP16,
Mhm,
and then you have like your cast to FP32 in the like the router code.
mhm,
Um, so there's like deep sparse, right? And deep sparse is optimized for like CPU. Um, when you run the deep sparse engine, you have like a test set. You look at like the activations at each layer, and then you prune them. So like you set them to 0, and then you just
So
like
it's
exclude
like
them from um
activation aware
uh
quantization or
yeah.
pruning. Yeah.
But this isn't like even quantization. Like in deep sparse, it's two steps. It's like the pruning thing and then the quantization.
Hmm.
Um, so this is CPU optimized because you have like a bunch of, I guess, like matrices with holes in them. Uh, the way they do it in deep sparse is like they put it vertically into like in vertical sort of slices. They put it into the CPU cache. Um, but we want sort of like horizontal slices, right? We don't want to have like matrices with zeros in them if we're running like GPU inference.
Hmm.
So we want actually like some kind of structured pruning. So we want like big chunks to be pruned instead of like small pieces, right?
Yep.
Uh, you so like yeah, so there's an application like you could prune a ModuleFormer. Um, First of all, you could prune it during runtime, so you could prune like well, I guess yeah, that doesn't really make sense. So you would figure out what domain you want it to use it for, and then you would sort of fine tune on that domain than prune. Um, but in the end, you would optimize memory. So like deep sparse, it optimizes memory by doing the pruning thing and then the cache thing, and then it also optimizes inference time by doing quantization. So this is like potentially a way for you to optimize memory on a GPU. And yeah, so like I mean, I'd want to see like, can you actually provide a better balance of memory to performance than a dense model when you factor in like, yeah, quantization, like all the stuff that people use. Can you have something that's smaller in memory, but has like better performance than a dense model? Because if you don't have that, then like you can't really use this for a lot of like a lot of sort of consumer GPU use cases, like open source models. You're running it at home. Like for a lot of those, you wouldn't be able to use um, an MoE model. So
There
that's sort of
really
the big
does
question here.
exist a reasonable baseline for converting and for making MoE model competitive with a dense model on both memory usage and performance. And that is in the switch transformers paper, there's this part where they attempted a distillation of their MoE
Yeah.
of the switch models to dense models, right? And it was like 30 1/3 of the way between like the dense model and the switch model, and it was like so it was slightly better already.
Yeah. But that was like with T5 and like who cares, man? Like no one really. Okay,
True.
I've been sort of roasting T5 a lot, but it's true. People don't use it at home, so like for a lot of these uh use cases, it doesn't really make sense to like use T5 as a baseline. It's like 3 years old now, Like I mean, I'd like to see something. First of all, decoder only, and second of all, something that approaches uh something like Llama.
Is there a assumption that the findings don't carry over from T5, or because of something different in the architecture, or what is or is it just like
Well, I mean, I
it's
don't
old
think
and it's hard to
I don't
tell?
think there's any like specific reason it wouldn't carry over, but like there's a lot of stuff that could happen once you actually like train the model and like try it out. Like
I think
there's a lot of stuff that could change,
Sure,
especially when you scale it up. Like that's the biggest thing. T5 is tiny, like Llama's
yeah.
like huge. So and it's what people actually use now.
I think
Uh,
it's a
there's even
T511B, and Llama's most experiments are still on Llama like 7B. So I think we can
yeah,
be
but
kind
like
into T5.
I mean, I don't know. I don't know. You could compare the like decoder, encoder, decoder, like large models to decoder only large models. I don't think it's like a good comparison. Um,
Yeah,
I think
seven.
it's still a different model.
enough have changed since T5 that it would be really hard to isolate the variables.
True.
Yeah, T5 is
And
T5 is pretty old. Yeah, here's my sources. Um, I didn't make them up, and
Incredible.
uh, that's the end of
I
my presentation.
I have
Thank
one
you.
quick question, if maybe you're a bit clear on this. So my understanding is that okay, so let's say the 4BK4 as it presumably uses fewer parameters in a forward pass compared to the Python 2.8b because of sparsity. Do you know what it's comparable to in terms of parameters used in a forward pass? Like, oh, it's comparable to like 500 million or 100? I guess it's 150 million parameter model. Um, is that does my question
Uh,
make sense? Or
you're comparing what Pythia to GPT. You're comparing Pythia 1.4b to like this MoLM 4BK2, right? Which has 2 times lower latency.
yeah. So what should be the comparable like
Well, I
forward
mean, they
pass?
have it up here, right? 410.
Oh, okay. Uh,
I would say that's pretty comparable.
There has to be slightly fewer activated parameters than that, right? Because the latency for the 4BK2 model is slightly less than Pythia.
Um, well, I mean, sure. Yeah. I don't know. I'd have to see like what the difference is in like because like MoLM they do the weird stick breaking thing. They have a bunch of like changes
Wait,
that Pythia
why on
doesn't
earth
have.
do they write down 25 gigabytes of memory for Pythia for 10M?
Uh, that's probably a typo. I don't think it's actually 25. Um, I'd
Hopefully.
probably yeah, just say that's a typo. Unless they have some kind of like secret Pythia like MoE whatever.
What
Yeah, I don't know.
why does 2.8 take up twice the memory of 2.7 on the second block?
Yeah,
On
these
third
are
block.
just. I mean, maybe Pythia is just kind of weird. I don't know like what Pythia versus GPT Neo.
I'm gonna guess they just ran like NVIDIA SMI and just like took the numbers naively without.
Yeah, but there's
They
no way
probably
it's
loaded the training
there's no way it's
checkpoints or
70.
something.
Yeah, there's no way it's 70. There's also like how is 2.7b like 35? Like I don't know. These don't make sense. Yeah,
Yeah.
thanks for calling that out. I don't trust these.
They including the activations as memory rather than like for
Well, like why would that be included as memory?
I mean, even the
I
activation
just
should
doing
be
it
really
backwards
small.
fast.
It shouldn't go that high.
Yeah, no, they would be like they would take up almost no memory. Um,
Yeah, so
yeah,
it might be an implementation difference between the two models, right?
well, yeah, but then this Pythia is like a terrible implementation because it's
Yeah,
it
yeah,
takes
that
way
might
too much memory.
be it. That's why the 410 takes as much memory as the 1.3B.
Okay,
Yeah, I guess I'll.
how positive do
Yeah.
you feel about this paper that you would think it would be worth trying to do further research on their architecture and like build on top of it?
Not very because they did a couple like they did this thing which is weird. I don't know why they added this. Uh,
What about
I
their
don't know why they
strongest idea?
changed this. I was trying to justify this. I actually don't like. I mean, I'd have to see like what this. I guess they did do ablations. Like maybe this works better, but um, yeah. I mean, they do already have like the Hugging Face code, so I guess that's like pretty nice. It's like the thing I said in the first slide, which is like, oh, we want to be like a llama for MoE.
Um,
So I guess
so
that's like a big positive.
they did use a decoder only model. They changed so many things that it's really hard to compare it. Heads up.
Changed like compared to what?
Just compared to if switch transformers, for example, where you change almost nothing except you add routing, the changes to like stick breaking and all of that is and doing different the different procedures for adding and removing
Yeah,
new
it's fine.
experts.
We can use like OpenMoE as a better baseline or something because that's
Yeah,
also decoder only and that's also they did an 8B model if I'm not wrong.
yeah. I was gonna say that I actually like OpenMoE more as like a project than this.
Agree.
Um, how does anyone remember how the 8B actually did? Like, did it do as good as like Llama 7B? Because I think that was like the biggest like hype like claim that they had, which is like,
Yeah,
oh, if we scale
I'm
this up,
pretty
it's gonna
sure
be
that
good.
that was complete nonsense. Like for one, they're checking Trivia QA, which is by far the best benchmark for hyping up MOEs. And number two, that was their projection for where it would end up after like X trillion tokens of training, not where they got at like 200B tokens.
Yeah. Okay. Trust me, bro. Trust me, bro. Uh, yeah. I don't know. I think someone will like eventually figure it out
Yep.
if it's possible.
Yep.
Because like, I mean,
Okay, no, there are very few people in the world
I think even
working
like a
on
dense model is
open
kind of
source
sparse.
MOEs right now.
Uh, well, we got a Discord server.
I mean, sure, but like pre-training.
Pre-training.
Yeah.
Yeah, pre-training. We might actually be able to do pre-training soon, but like we would have to have a good reason.
How many GPUs?
Don't worry about it, man. Enough.
I think
Uh, enough. Yeah. But like, yeah, we'd have to like we can't really be like open MoE. Like if the like I guess if open MoE isn't that good, then like why would ours be any better, right? Because we're using the same methods. So I'd have to think about it. But
There's probably some significant room for optimization in like, I don't know, applying MUP or something else to MoE.
maybe. Yeah. But that I mean sure. That would just be like experiments, and those are expensive.
Well, I mean,
Um
the point of maximal update parameterization in particular is that so that you can do cheaper experiments and scale up.
yeah, maybe. Um I think Microsoft could probably do that if they want. That'd be nice.
Yeah, would be nice.
Uh yeah, I don't know. Yeah, my overall opinion is kind of like medium, like neutral because I like the module thing. I think it's cool that it works because they're literally just like adding a new row, which is like super simple. I thought they would be doing some kind of weird like code book thing or something to get rid of the like the router dimension, but no, they're just like adding a new row and deleting a row. Uh
Is okay, but what's the actual use case for, because the ability to take away and add experts is done with the priority of being able to fine tune on a large domain, right? So
yeah. Yeah, that's why I'm neutral. Also, okay, so they did this like experiment with coding, right? And it's like, oh, we could make it good at coding if we apply our method. But they're totally ignoring that, there's models that like Phi 1 that exist now that have been coded that have been trained on like a special been pre-trained on a special like synthetic data set, which do super well for their size and probably like way better than this model could ever do.
yeah,
And that's actually like that's the same goal there. You want a domain specific model that takes up less memory and takes is faster. So yeah, it's like if you can't make this method like clearly better than that, then I guess there's really no reason to put in the work to like actually refine it and like code the like make inference code that like does the pruning and everything. I mean, yeah, I don't really know. Okay. Does anyone else have questions or like anything they want to talk about?
I feel like Phi 1 is a bad comparison because for Phi 1 and all of the other GPT-4 distillation models, like you need to rely on the existence of this existing better expert that can create a well-formed data set for you to begin with, right?
Uh, yeah, but I think that's not that big of a problem. Like, okay, so I'm focusing on like okay stuff you could run on your and for that use case, there are already like massive models like GPT-4, whatever Google's working on, like Gemini or whatever, or they're like uh the the big models they trained before, like one of them is probably good and they could use it for like essentially generating a data set, right?
Mm-hmm.
And for this use case, like yeah, you could get something that's better than like training from scratch. I mean, I don't
That's
think
true.
people have like if you have the resources, you could make like a good synthetic data set now. Like if you just
Yep.
literally if you just pay for API calls, you could make it. So
My sense is that where they see this being useful is when, let's say, you already have a very, very good, let's say, GPT 3.5 level model, and you want to teach it something new, either like tool use, a new language, a new programming language, and this is how you could extend. This is one way you could extend it, with hopefully minimal impact to its existing capabilities. That's where I think they see this being useful, which is like there's like 3 qualifiers I added in there already to justify it, but
Yeah,
this
like
isn't uncommon for
the,
this
the
project.
first biggest sus thing would be whether you how often it occurs that you have a new task and domain that is so novel and so large in breadth that you need a new actual entire expert rather than simply applying a low rank adapter layer or something.
Yeah, which is like, okay, almost never. Like, when is that going to happen? I mean, maybe for like some kind of business use case, which like,
I would actually
Yeah,
think the
so
main use
I'm
case
thinking,
is new languages. Sorry, go ahead.
yeah, new languages, tool use, something that's, yeah, I would say business and domain specific. I don't think this is intended for person with a GPU at home to use. Yeah.
yeah, maybe I'm coming at this with like an open source perspective when this is from IBM. So they're gonna want like IBM, a model that's useful for IBM. Maybe that's where they're going, what they're going for. Uh, yeah, that's a good point.
New languages are interesting, but even then, unless you have a really, really spectacularly large training run, I suspect that in most cases you would just want to, you know, add the new data to a data set and retrain.
Yeah. All right.
What?
Sure. Go ahead.
Oh yeah, I was gonna say one example could be you want to ship this model to some company internal like co-pilot alternative, and you want to train on
And
their
you want a
internal
very
code base.
small on-prem solution.
Yeah.
That could actually work really well for OpenAI.
They're not shipping out their models to anyone, right?
Yeah, they
I guess
aren't.
maybe Cohere will
But
do it, but yeah.
they have a lot of demand for this on-prem thing, and like even if they didn't have a problem of model weight leaking, it would be horrible for them because you need like 8 DJX nodes to just run one instance of GPT-4, and if you could distill that to a single expert better than existing techniques, then maybe it could become really useful.
So if the rumors of them working on an open source model at all are true, maybe that's what they'll do. They'll have like a separate model that they train that's designed to be like, not dangerous, and like we can ship it on prem, and if it leaks, it is what it is. And they'll sort of like put the OpenAI brand on it and like ship it off to these on prem solutions. I can see them doing that. Or
Yeah.
Microsoft will do it, I guess.
I think Microsoft probably has access to GPT-4.
I mean, some people.
Yeah, but I don't think they can freely like ship it out or copy it out or anything. So I think it's pretty restricted what they can do with it, which is why all the research papers are on how can we distill from GPT-4.
Yeah. It's like,
yeah, what's funny is like Orca, they actually paid for the API calls, right? And that's Microsoft, so it's kind of weird.
The funniest thing is not only do they pay for it, they put somewhere in the paper that like we needed to like find multiple API endpoints to query faster.
Yeah. And they also couldn't use GPT-4 for some reason. I think like they ran out of money or something. So
which is really weird when like 100% of the profits are supposed to go back to Microsoft anyway. It's like dog food eating themselves.
Cloud vendors are really bad about that. Like, yeah, the cloud, basically the cloud people as a business unit frequently just outright refuse to eat any cost or give any sort of internal pricing. So it wouldn't surprise me if other business units can't actually utilize them the way you would hope they could.
Makes sense.
Yeah. All right. Cool. If no one has any questions, then I'm gonna stop streaming.
Do you think this presentation was? Actually, never mind. I have no questions.
Okay. Yeah, it was a good presentation. It was short and sweet.
Wonderful.
All right, cool. Thanks everyone for coming.
Oh,
yeah?
Go ahead.
Oh yeah, go ahead, man.
Oh, I was just gonna say the main issue is that it wasn't a Gnome Shazir paper, so.
Yes, absolutely,
Yeah, that's the
100%
problem.
true. Are there any Gnome Shazir papers we've missed, like so far? Like what's on the list to cover next?
Big ones or in general? Here's a good number.
Are we at some point doing the soft MoE one?
As soon as somebody in the community comprehends the paper in its entirety, we should do it.
Did we? I thought we did soft MoE.
We did?
Was that like at the end of a different one? That might have been at the end of a different talk. We like got into it.
I think we're always like hinting at it of like, oh, but this is covered in that paper, but we never.
Yeah, exactly.
Okay.
I mean, I'd be down to do soft MoE if people are interested, but it doesn't really work on decoder-only models. That's the main bottleneck right now.
Okay, the absolute best person that I would like to have present is someone that has an idea of what the fundamental difficulty is in preventing information from leaking between the different slots in the soft MoE architecture. Aside from
yes, I implemented it and I had this problem, and yeah, it was pretty obvious that it was leaking because like the model just ended up performing like almost like it was like an oracle. If you just did it for decoder only, and so yeah.
Is there? Do you think that there's any potential solution aside from having a number of slots that's equal to the number of tokens?
Yeah, I feel like that would be the main one. Or if you had the batch, if the batch was like so huge, then you could like potentially trade off sequence length for batch. So for like OpenAI, someone who has like so many requests coming through at a time, you could try something like that. But yeah, it'd generally be pretty hard.
Fuck. Okay then.
I don't know if other people have different opinions on that. So yeah, very open to other people's thoughts.
Need some way to only mix backwards. Yeah, I know. But are you open to presenting it next week anyway?
Yeah, I'd be open to it if people are interested.
Yeah, I'm pretty sure everyone in the entire community would be really interested in actually understanding the paper that basically, kickstarted this entire reading group.
Soft MoE, more like hard MoE.
Artem. Okay, let's end the call here. I'm going to start recording.
All right.